So, hello, assalamu alaikum everyone. So, it is actually Global Azure Bangladesh, and this is for the first time we are going to arrange Global Azure Bangladesh, and it's completely online. Okay, so let me introduce you to the rules or how you can get some swags from this actually Global Azure and what is going to happen today. So let me share my screen and yeah. Okay, so if we just start from here. So it is the Global Azure Bangladesh. So as you know, what is Global Azure? If I need to know, mention. So Global Azure is something like for the 3 days from May 11 to May 13th. What we are going to do, the developers, all the from the world, is going to actually talk about Microsoft Azure. So right now for Bangladesh, we are going to arrange this one. So today it is going to start from 6 p.m. So we have just started late because of some issues, but surely it's going to end sharply at 10 p.m. So you can stay up here. Okay, so this is our speakers panel basically. So you can see there are lots of speakers, and surely there are like Microsoft MVPs, most valuable professionals, and also there are like Microsoft partners as well. Okay, so mentioning about like day one sessions. So today, so what it is going to happen is like, first of all, from my end, it's going to be like introduction to Microsoft Azure and Azure for Students by Shahriar. So that's my session. So after that, from 6:45, or maybe it might take some time a bit, maybe from 6:50. So we are going to know about introduction to IoT with Azure by Major. And after that, from 7:30 to 8:15, so we are going to know about Microsoft Security Copilot, and it is going to be like a session by Clairo, Ronels, and Eduardo. And from 8:15 to 9 p.m., it's going to be build and deploy ML models by obviously Nur Fatiha Tahessiam. So, and there are consecutive 2 sessions from her, and so that was it for today's session. It's going to start from 6 p.m. and end on 10 p.m. So this is our planning for this one, and there is something essential I want to mention. So this one, want to get a GitHub T-shirt. So generally, what we know, so like in global, if you attend some sessions or something, you might get some flags, right? So physically, if you attend some place, you might get some flags. So we want to ensure that you want to get a swag. So today, the most active person in the chat will get a t-shirt, and we'll mention it in our Facebook group as a tech group. And after that, surely there are other swags like LinkedIn Premium vouchers and Xbox as well, vouchers as well. So you can also claim that. Okay, so that was our introduction to the like kind of Global Azure, like or the conference we are going to actually arrange. So it is day one. The day two is going to be the next one, May 12th, and the day 3 is May 13th. So sharply at 6 p.m. it's going to start and end on 10 p.m. I hope there is no questions left. So if you have any questions, kindly actually mention that or comment that in our YouTube live stream or Facebook group, wherever you are. Okay, now let me actually show you the Global Azure page as well, like to if you. Okay, so Global Azure page. So whatever I mentioned, like Global Azure. So it is currently, you can see if we just zoom out. So from Bangladesh, we are arranging from Bangladesh Azure Tech Group, and there are other several. You can see there are a total of 99 communities and 104 locations around the world. And here, if you have any questions, you can see up here, and also the speakers and sessions are actually mentioned up here. Okay, so that was something if you need to know about this one, like what is Global Azure. I mentioned that. Yeah. Hello. Hello. So yeah, thank you for attending the session, and we hope to start the session from 8:15. And we are just 1 minute ahead, and you can start by introducing yourself, and then you can start. Okay. Once you're ready, you can tell me, and I will go to the backstage and get the floor to you. Yeah. Okay. Add to the stream. Okay. So let me move to let me go to the backstage, and you get part of the host. Okay. Best of luck.
Okay.
Thank you.
Thank you. So hello everyone, this is Nur Fatiha Tahiyat Siam, and today and in this session we will be talking about how to build and deploy an ML model using Azure Machine Learning Designer, and I will be the one heading you all with the journey. So this is me, Nur Fatiha Tahiyat Siam. I'm currently doing my graduate studies in the Department of Computer Science and Engineering at Brack University. I'm a Gold Microsoft Learn Student Ambassador, and I have 5 Microsoft certifications. As of my career, I'm working as a senior manager in the Department of Research at an NGO named Bangladesh Extension with Education Services. And yeah, here are some of my social media handles along with my student ambassador's mail. So make sure to reach out in case you need any sort of assistance. I will be happy to help. So what is our today's agenda? First of all, we will be talking about what's machine learning. We will explore the aspects and the approaches of it, and we will get our introduction to Azure machine learning, and then we will be heading on with our hands-on experience with building a predictive model with Azure Machine Learning Designer. And lastly, we will quickly wrap up with some cost management tips. So for now, does it seem a little bit too much? So don't worry, we will cover it up very smoothly in the upcoming time. So let's start. What's machine learning? Machine learning, according to Stanford University, it's the science of getting computers to act without being explicitly programmed. So what do we mean by act? Like, how do we want our computers to act without being explicitly programmed, right? So here comes another definition where we can see that Udacity says that machine learning, it brings together computer science and statistics to harness that predictive power. So yeah, now we can get a little bit of idea that what we expect our machine learning concept to do. We want machine learning to bring or harness our predictive model by combining computer science and statistics. So does it mean that machine learning only involves computer science and statistics? It doesn't involve anything else, like any other field isn't involved? So yeah, machine learning, it involves programming, statistics, mathematics, and intuition. So it is the most important thing. If you're working with data and you're around data science, so you must know that intuition is the one thing that will lead you to the long way. Now, let us look at some of the machine learning approaches. So first of all, we have supervised machine learning. So one thing I need you to remember is whenever we are talking about supervised machine learning, it is correlated with a data set which we call a labeled data. So yeah, machine learning, whenever we are dealing with supervised learning, it has the data set which is a labeled data set. And the computer is presented with some example inputs and their desired output. So here, it's the one thing I'm talking about. So we have our desired output or labeled output already within the data set. And our goal is to learn a general rule that will map inputs to outputs. So we use supervised machine learning in cases of predictive, in case of predicting a value, or we can use it for tasks like feature engineering. And okay, moving on. And the second part, we have unsupervised machine learning. So whenever we're talking about unsupervised machine learning, on the opposite, we have unlabeled data. So no labels are given to the learning algorithm whenever we're trying unsupervised machine learning. So we are leaving the system on its own to find the structure in the input. So the system, it will find the structure within the data set. And yeah, we can use unsupervised machine learning to do works like discovering hidden patterns, or do anomaly detection, or do feature learning. So these are the kind of tasks we can perform with unsupervised machine learning. So moving on. On our third, here we have reinforcement learning. So reinforcement learning, it is about that computer program that interacts with a dynamic environment in which it must perform a certain task, and it gets some feedback. So based on the reward or punishment analogy it gives. So a very famous example about reinforcement learning goes like, suppose we have a baby of 1 year at our home, and one day our baby, he or she sees fire. So at a distance, from a distance, he or she will feel like, yeah, fire, that's shiny, glittery, sparkly. So he or she, at the very first instance, he or she lights the fire. And then what he tries as a baby, he or she will try to go towards the fire. So as long he goes near the fire, what happens? He or she will feel heat. So from that heat, he or she will get a uh, like get a signal that that fire isn't something that beautiful, it's something dangerous. So from then on, the baby will try to be far from the fire. Okay, so he or she will not feel the same way that he did earlier, whenever he's seen fire. So yeah, that's the concept that machine reinforcement learning implements, that reward or punishment analogy. Okay, then on our fourth, there is semi-supervised learning, where we use a portion of labeled data with, compared to the portion of labeled data, we have a bigger portion of unlabeled data. So with the combination of both labeled and unlabeled data, we use semi-supervised machine learning. So yeah, moving forward, so at this point, so what is your reaction? Like, we are talking about, we will deploy a machine learning model as a web service. So what is your reaction now? Is it like you don't know how to deploy a model? Oh, sorry for that. So you don't know how to deploy a model, and you're too afraid or shy to ask, or you're something who's like, whose head is full of knowledge and who's about to like explode with that knowledge within yourself. So in which category do you feel that you're in? Let me know in the chat. Unfortunately, I'm not being able to access the chat right now, but I will definitely check it out later. So yeah, let's move on with some examples of machine learning. So first of all, we talked about supervised machine learning, where we like emphasized about our data set being labeled. So here we can see the example that we are feeding our system with some data of some pictures of cat, and the label here is cats. And then when our machine or our system is trained, then we are giving it some test data, where we can see that we have two types of cats, and this one, it's not a cat. So what our system predicts or system classifies, it classifies these two pictures are correctly as cats, and this one, it's not a cat. So the machine, it doesn't bother itself with that, whether this picture it's of a dog or any other animal. So it knows what's cat, and it can say that, yeah, these two are cat, but this one, it's not a cat. So yeah, moving on, we can use supervised machine learning for the tasks like classification problem, where we can use algorithms like two-class logistic regression. We can also use decision trees, and yeah, support vector machines. And whenever we're talking about regressions, yeah, we use regression in cases like predicting a value or predicting a future number. So yeah, that was an example of supervised machine learning. Now it's time for unsupervised machine learning. So in this case, we already mentioned that our data set will not be labeled. So we are feeding our machine some pictures, but the machine, it doesn't know that whether it's a cat or a dog or whatever. So based after the training happens, what the machine produces, it produces two clusters of like data sets, as it groups one similar picture, one kind of pictures into similar group 1 and another to similar group 2. And in what kind of scenarios we use unsupervised machine learning? We use it for clustering, just like we did here, and we also use it for anomaly detection. So now let's come to the topic. Why do we use Azure machine learning. Azure machine learning, it's a cloud-based environment that we can use to work from scratch. We can start working from our data sets, and we can start working from training, deploying, automating, managing, and we can also monitor our ML models within the Azure platform. So it's a platform that offers a whole bunch of services, and therefore it can also be used for any kind of machine learning, from classical ML to deep learning, supervised or unsupervised learning. So we can use it for like almost any kind of machine learning approaches, and therefore we also have the freedom to write our own code in our desired language. Like we can use Python or R code with the SDK, and we will also have the flexibility to work with no code or low code options. So this one we will be checking it out in a bit, so stay tuned. And lastly, we can start training our model on our local machine, and then we can scale out to the cloud. So Azure machine learning, it also provides us the opportunity of scalability, where we can start from our local machine and then scale out, and we will also have the flexibility to scale in and scale out anytime. So we will have that elasticity. And also, Azure machine learning, it's a pay as you go service. So you do not have to pay for these resources you do not use. You only have to pay for those amount of, either it can be compute resources, it can be memory resources. For you will have to pay for only those portions that you use. Azure machine learning, it offers us AI for any skill level, where we have automated ML. So in this case, we will just upload our data set, and we will select which algorithms we want to on which algorithms we want to train our model, and voila, we will have our model trained. And therefore, here comes Azure Machine Learning Designer, where we can simply drag and drop our data sets, our algorithms and our evaluations into the pipeline, and we can into the designer board, and we can build our pipeline very smoothly. And lastly, we have Azure notebooks, where we will have our full freedom to write our own code in the language we prefer. Just the thing I discussed earlier, that if you have no code experience and no ML experience, you can go for automated ML. Like I just mentioned, that you just have to upload your dataset, and you will have to upload. You have to select your algorithms, and if you don't have no code experience, that means if you have some sort of experience with coding and some sort of experience with machine learning, you can go for ML designer. And lastly, if you are a pro, like if you are someone who's if you're a coding person, is your ML notebooks is waiting for you. Now, enough of the theories, we can simply move on to our ML deployment. Okay. So I hope by changing the screen it's still visible. So can you please confirm? I hope it's visible. So yeah, we are on our Azure portal, and here on our Azure portal, first thing we have to do before creating any sort of solution that we may build, like it may be static web apps or anything else, we have to build a resource. So in our case, we are going to go ahead and build an Azure machine learning resource. This one, I can see we're running out of time. So I'll just go ahead and create a Azure machine learning. Here you have to select the resource group you want to work with. It can be a previously created resource group, like what I have here is Fatiha diabetes prediction, because we are going to work with diabetes prediction in a while, and we can give it a name like this prediction. Yeah, we don't have to be bothered about the rest of the things. We can let it be created in a while, and just to save up some time, I will go to the previously created resource that I have already. So after the validation is passed, you can click on create and your resource group will be created. And in Azure, just if you want to have a workspace, you have to create a resource first. So in every resource, we have workspaces, and under that, we have our compute things. So yeah, let us. Okay, the deployment is in progress. It will take some time. So within this, we can simply go ahead into the machine learning workspace that we have already created. So after we have our resource group created here, we will be launching our studio, and which will be our workspace. And this is how the workspace looks like. So let's launch the studio. On our Azure Machine Learning Studio, we will have options like Notebook, Automated ML, and Designer. The three of these we have already talked about. So you know what each of them are. Our data, how jobs, when they're done with their status, they will be stored here, and so on and so forth. You will get to know them eventually. So before creating any machine learning model, we must have our compute instances on run. So here, what I will do is here you can see that my compute instance is on stop, because it takes about a lot of money when you keep your resources on run. So after deploying any of your machine learning model, make sure to stop your compute instance. So for simplicity, I will just go ahead and show how to create a compute instance. So you have to give it a name, but before that, you have to choose which kind of virtual machine size you want. So here you will see that some we will select from all the options, and then you can see that in the category there are some VMs that are that have the category of memory optimized. Some are general purpose, and we have also some of them which is computing optimized. So what does it mean? So let's talk about it while creating our DS11. DS11 is a memory optimized VM. So in memory optimized, we get more memory than CPU. In in compute optimized, we will have more compute resources than memory, and in general purpose, we will have a balance. So let's give our compute a name like global Azure instance. Does it make sense? Yeah, it does. Then, okay, while it's being created, we will go ahead and create a compute cluster. You can see there is already one running, but I will still show how it's created usually. Then in this case, I will forget that. I will choose a tier that's dedicated because I have like some sort of credits left, and from all the options, from all the options, I will again select DS11. Yeah, it was like once it was like $0.15 per hour, but that was cost. Okay, so let's give our cluster a name. What about global is your cluster? At our minimum node, it's 0, and maximum node we will be selecting 2. Okay, so let's go for 1. So what it does, whenever you're not using the resources, it will scale down. And okay, so this is how you will just create a cluster. I will be leaving this. I have one already. Then we will come about data. So by then, let's check that if one of our compute instances is on run. So we don't need another one. Let's just let it be on 3. So you can see that I have these diabetes data on which we will be working today. And now let's head towards the designer. Let's quickly give it a name. Right. The first thing we need to do is to drag our dataset onto the pipeline. And whenever you're working with data, make sure to explore the data before you start working with them. So don't be impatient and start working before. So on our data, we can see that we have columns like patient ID, pregnancies, plasma glucose, systolic blood pressure, triceps thickness, serum insulin, BMI, diabetes pedigree, age, and diabetes. So we already talked. So here you can see that this diabetic column, it only contains values of zeros and ones. So yeah, it is the thing. It is the one label data we were talking about. So now you have the idea that today we are going to build a model which will be a supervised machine learning model, right? So, yeah. Okay, after going through the data set, we can start by normalizing the data. So now you can ask that why we do need to normalize that data, right? So I have a question. There was a column. Oh, another thing. So each of the column is called a feature, and each of the rows are called examples. Okay. So we had a feature named patient ID. So does patient ID contribute to a patient to be diabetic or not? Does it? Suppose I have the patient ID 1 and I am not diabetic, and someone is 2, he is diabetic. 3 comes with no diabetes. Does it mean that 4 will have diabetes? No, right? So we are not going to normalize this feature. So we will be going ahead with pregnancy, plasma glucose, diastolic blood pressure, triceps thickness, and all the other thing we have. But now, should we add diabetes? No, because that's the label data. Okay. So after doing the normalization, what we will do, we will split our data. So that's what we call train test split when we are working with real codes. So here we have the flexibility to keep the 80% of the data for training purpose and 20% for testing. So after we are done with train test split, we can go ahead and select an algorithm on which we want to train our model. So for now, I want to select 2 plus decision. 2 plus boosted decision tree, because it gave me the maximum number, maximum accuracy. I will be showing it in a bit that then we will train our model. Where is my train model? Okay, here. So after we have our algorithm, we will connect it to here, and after we have our data set, we will connect it here. So now, and we will have to give the label data set name. So what was it? It was diabetic. After we put our label data here, we can keep the model on. Sorry for the noise. After that, we will score the model, and here we have to put the test data set portion, the 20% of the data which we left for testing, and after that we will evaluate them. Okay. So now, as we are running out of time, I will quickly show move ahead. Okay, so another thing, after your your pipeline is created, you can simply submit it here. So for now, I will go ahead to jobs and show you a very interesting thing. So remember, I mentioned that I will be using 2 plus decision. Yeah, let's see this one. 2 plus decision boosted decision tree, because it gave me maximum accuracy. So now I would like to show you one thing, that here I trained the exact same model with four different algorithms. One was 2 plus support vector machine, 2 plus logistic regression, 2 plus decision forest, and boosted decision tree. What I gave from the evaluation, from the okay, so from the evaluation, yeah, from the evaluation we can see that here on the left port we had 2 plus support vector machine. On the right port we had 2 plus logistic regression. So both gave us similar result. So one gave us 76.8% of accuracy, which was SVM, and one gave us 78.4% of accuracy, which was logistic regression. And we had our like precision recall F1 score and this 2 by 2 grid, which here is our true positive score, and this is our true negative score. Okay, as we are running out of time, so yeah, from here I can show you that here we had another two of the algorithm, which was 2 plus decision forest and 2 plus boosted decision tree. So now we will look closely. So, yeah. On the right port, we have 2 plus decision forest, which gave us 92% of accuracy. So that is something like incredible. And what's more incredible to it is this 95.1% of accuracy. So yeah, boosted decision tree, the iterative algorithm, it worked. So that's why I kept the decision tree algorithm here. And yeah, after training your model like this, you will have all check marks if nothing goes wrong, and then you can create your inference pipeline from here. So this will lead you to something I will show you in Puppet. Leave it like this. Yeah. So it will take us, so from there we will have to select the specific algorithm on which we want to deploy our model, and there we will have to give this type of this input and output. So whenever you then you will enter data manually. As we're running out of time, so we cannot like, entirely show the ML model as a web service, but we can surely we can test it out here. So here in case of enter data manually, where we're after the deployment when we're about to test our data set, like what we discussed in our supervised machine learning slides. So here let's just quickly test with something like we have our patient ID that's not going to contribute. So in the pregnancy number, there is just one woman who is one pregnancy, plasma glucose. Okay, let's just increase her glucose to directly. So let's just do it to. Isn't it working? Okay, sorry. I'm in the jobs section, so it cannot be edited. So okay, I will show it directly from here. So whatever data that was entered, I will be showing this code model from here. So here I can see that there was 3 test cases, and all the 3 of them were non-diabetic because we can see that score level is 0, and all of the 3 of them did not have diabetes. And yes, because yeah, the pregnancy was either 0 or 1, and the plasma glucose, it was really up to the mark. And based on these data, our machine predicted that these persons were not diabetic. So yeah, let's just go back to our slides. Yes. So we are done with our ML model deployment. If you have any questions, please do ask. And lastly, we have some tips for managing cost. So whenever you're like working with training clusters, so configure your clusters. What I mean is set the node to 0, like I shown in the demonstration part. So set the node to 0, it will automatically scale down your like machine learning uh, resources. So, and also you can set quotas to your subscription when you have multiple subscriptions, and it will also help you to configure your cost limit, or you can manually do that from the portal. And then you can also set termination policies on your train run. So you can set time limit or minimum accuracy required. So suppose you have an algorithm that keeps on running, but if you set a minimum accuracy required, then it will stop after some iteration. And therefore, you can use low priority VMs, and do not forget to stop your compute resources, like I showed in the very first stages of our deployment. Right? Do not stop computing resources, because I once forgot to stop the resources and I lost like around 100 of my credits. So it hurts a lot. So I hope you understand, and delete the workspaces if you do not need them anymore. Here are some resources you can go ahead and check out. So yeah, we're done. Thank you. If you have any question, just feel free to ask. So I would like to call home if there is any question. Okay, so the deployment that started at the very beginning is now complete. So let's show what it looks like this. If there is any question, please let me know. I was audible, right? Should I just go on and start my second session? I wish I could see something where I could show some responses, see some responses.
Okay, so it's the time for the quiz, right? Some sort
Yeah.
of Q&A, right? Okay, so starting with this, how does Azure machine learning perform for large data sets and complex models?
How does your machine learning perform for large data sets and complex models here? So yeah, so for large data sets, we need to have more compute powers, and for complex model, yeah, again, we need to have some more compute power or memory. So yeah, it will cost a bit more, not a bit more, it will cost like a lot more, but still it on Azure machine learning you will be comfortably working on complex data sets. Okay, let me give one example of TransLink, a Canadian company which have 18,000 models deployed on Azure, and they have successfully they have decreased 50% of their waiting time for their customers, and they have increased 74% of productivity. That's huge, right? So it works.
That's great. Okay, so there was another question like, so how can we deploy the ML models as a website?
As many as you want, as many as you want,
I think
depending
it
on
mentioned
what
how can
subscription
we?
you have.
How can we?
Okay, how can we? How to answer this one? Yeah, like how can we deploy ML model as okay. So here the thing is, we were talking about web service, not a website. So what web service mean that we can deploy our model like on real time. If I deploy it as a web service, so you will be able to like access it and test it from like where you are here, like from where you are now. So that's the case of web service, but not a website. We can like integrate it some way and then website, but we cannot deploy it as a website.
Yeah. Okay, so we didn't have that much questions for this one, but yeah, I did ask a question like anyone learning machine learning here. So there was a question like not question. So Atul mentioned that he has done a project in ML, so that was awesome.
That's
okay,
great.
and also Janul mentioned that I have learned Pandas, Seaborn, and Leap, and so on. Still learning. Okay, so I would like to add I would like to add the question is like, what would you suggest to learn more to Jainul, right? So as he's learning right now, so maybe you can suggest something like this kind of things you should learn for mastering machine learning and so on. So what is your suggestion?
So like mastering machine learning is like, my suggestion would be keep on exploring. It doesn't matter which website you're using or which like courses you're taking. So keep on exploring. It doesn't matter from where you learn, but keep on learning.
Okay, great. So yeah, okay. So I think we have another session, so you can just start with the next sessions because we don't have any questions left right now. So yeah, let's back to the next one.
Okay, so give me a minute to prepare the resources. Once
Okay,
I'll be
so
done.
there is another question. Yeah, another question like, which level of mathematical knowledge do I need before starting to learn ML?
So yeah, as for mathematical knowledge, you don't need like very high level something. It's just about simple linear algebra that we learned and something about calculus. So you can start from the very basic mathematics. So yeah, it won't be hard.
Okay, I would like to add some more here. So for the mathematical parts, there's recently a course launched by, I think, deeplearning.ai. So you can just ask for the financial aid for that. And there are a few things you will see, like kind of curriculum or statistics, basic actually, what do you say? Yeah, calculations, algebra, this kind of things. And yeah, so all of those courses are actually packed in a specialization, and you will get that for free. I think that would be enough, right? Those kind of, okay.
Even if that's possible, you can share the link with them. It's
okay,
on Coursera, yeah. Right?
Yes, it's on Coursera.
So
yeah,
okay, so let me share my screen again for the second.
Okay, so I will add that link to the, yeah, I will do that. Okay. Not for the second session. Okay, so when you are ready, you can mention, right? Yeah, I think you.
Yes, I am ready.
Let me add it to the stream.
Okay, is my screen like on show now?
Yes. Okay, so there is another question. Okay,
so our second session here.
There is another question left. Okay, yeah. Because I don't know, when we are just ending our Q&A, people are asking some questions. So the question is like, should I start learning machine learning before doing DSA? So what did you suggest about the DSA and machine learning? Oh, what is the relation here? Or what do you say? What would you say? Because I think it's not actually a typically machine learning question, rather a question like what should we prioritize, right? So what is
So
your
it's
opinion
better
here?
to start, like it's better to have some DSN knowledge beforehand, but it's actually not necessary. But yeah, I think Mitul, you can answer the question as well because you
Okay.
go around work with DSN, right? Like data structures of targets.
Okay. So if I would suggest, okay, let me remove this one. So should I learn learn machine learning before DS or something like that? So actually, machine learning, if I would suggest, machine learning is not actually for the complete beginners. I wouldn't suggest you, because obviously there are the mathematical concept. Okay, so integration and there are lots of things in those mathematical concepts should be covered. Okay, so you should target learning first year or second year, or at least first year completing DSM. That would be helpful in your interview round or something. And also for the machine learning thing, meanwhile you have to complete your mathematical basics, which we mentioned about that course one, and then you can continue your machine learning, I think. So then you will not be stuck in the process of you will not understand. There will not be a situation like, oh, I don't understand the basic mathematics for here, how this algorithm came up or something like that. Because
Yeah,
yes, obviously there is cloud service like Microsoft Azure, obviously AWS and GCP and so on. They are actually ML solutions. But if you want to if you want to learn from the core, obviously you need to learn machine learning from the core as well. Obviously
yeah.
you can use machine learning services from the cloud as well. There's no problem. Okay, so I
Still,
think there's no, yeah, I think there's no actually questions left. So if you're when you're ready, I will share this actually stream, share your slide or skin to the stream. Yeah, let me know.
okay, you can put it up, I
Okay.
guess.